Dear student, today we see that chromatography topic, especially in the GOC unit of organic chemistry. Okay, here it's a chrome means that is for color. Okay, it's a color. Graphy, this graphy means that is for separation. Separation. So the mostly it's a colored compound separated from the natural product and the minerals, whatever that. The colored product can be separated initially. Okay, so the components of the chromatography, components of chromatography. Okay, so this component of chromatography, first one as a stationary phase, and the second category as a mobile phase, and the third one as a solvent. Okay, so first of all, the stationary phase as a fixed phase cannot be movable. Okay, it's a fixed phase, and the mobile phase as a movable phase. Okay, the solvent as a depends on that compound or sample, the polarity increases. There's a polarity increases or there is a decreases. Okay, we can take based on that our sample whether the solvent is a more polar or there's a less polar, depends on that. Okay, then next there's a principle. There's a principle. This principle actually generally based on that stationary phase type, whether the solid or liquid, depends on that. The principle is classified as two types. One is adsorption principle, adsorption adsorption principle. Okay, and second one is a partition partition principle. Okay, so these two principles are in the chromatography. Let's see that what are that kind of principles, and as well as that principle where which chromatography is obeyed like that. Okay, so this adsorption here, the stationary phase as must be for solid. Okay, and here partition principle, here the stationary phase must be as a liquid. Okay, so these two is a very important. There is a types of chromatography. It's a types of chromatography. Okay, so the first case as a column chromatography, second as thin layer chromatography, that's nothing but TLC, and the third one is a paper chromatography, and fourth one gas solid chromatography. Okay, and the fifth one gas liquid chromatography. Okay, and there's a sixth one as a ion exchange chromatography. These all are only are presented in the chromatography topic. Okay, in the column chromatography, a stationary phase as a solid, and mobile phase as a liquid. Okay, and TLC here, stationary phase as a solid, and mobile phase as a liquid, and paper chromatography here, the stationary phase as a liquid, and mobile phase as a liquid. So these are both as a liquid phase. Okay, both as a liquid phase, and gas solid chromatography here, there's a stationary phase as a solid, and the mobile phase as a gas. Okay, the next gas liquid chromatography here, stationary phase as a liquid, and mobile phase as a gas. Okay, this is a very short term. Okay, then here the ion exchange chromatography here, they have elucidation as well as the ion exchangeable resin can be exchanged by the suitable cation. Okay, let's say here the ion exchangeable or ion exchangeable resin can be exchanged by the ions. Okay, so this is for example the alkali metal ions, alkali metals, and alkali earth metals. Okay, as well as there's a rare earth metals of D and F block elements, especially F block elements. These all are there is separated from the ion exchange chromatography, especially these lanthanide elements as well as actinide elements. Okay, more always there is a lanthanide elements is much more separation compared to the actinide elements. Next is the types of chromatography, especially the column chromatography. There's a column chromatography. Okay, so this column chromatography here, the stationary phase as a solid, as well as there is a mobile phase as a liquid. Okay, the solid of stationary phase, especially there's a silica gel, it's a silica, as well as alumina, gelatin, so like that, etc. So these are all used as a stationary phase. The mobile phase as a water, as well as there is a ethanol, ethyl acetate, okay, etc. So these all are used as the mobile phase. Okay, this the silica, alumina, gelatin, these all are used as a stationary phase. Generally, the column is like the shape of a burette. This is a column. This column, it's like that is there. Okay, here is a small hole is presented. So we can fit on that column in the stand. Here, this column initially a small cotton we can use it here. It's a cotton because after the packing in the stationary phase, that cannot come to here. Okay, so it's like that. The next, the stationary phase plus our sample make it make it a the sample plus stationary phase make it a slurry, that is by using of the small amount of the solvent. That slurry filled in that uniformly without cracking in that column. Okay, we can fill this column, and then next again here we can fit on that cotton. Okay, cotton. Then now we can add that the solvent with a suitable polarity, because in our sample we can find out whether there is a more polar less polar, depends on that our compound. Okay, because more electronegative atom is presented, much more that compound are more polar, then only we can choose that solvent as a more polar. Here the compound and sample or stationary phase, they have adsorption principle. There is a compound come to adsorb at the surface of silica gel. Suppose here more adsorption, lesser elution, lesser elution. Okay, so these two as a inversely proportional. So generally adsorption inverse of elution. Okay, okay, so this is a very important because some compound like amine compounds, so they have more strongly affinity with the silica gel. That's why that's a very less quantity of elevated, or otherwise we can add that more polar solvent. Okay, so whenever that more polar solvent we can add it in the especially stronger affinity of the compound as well as the stationary phase containing compound. After the addition of solvent, the mixture of that compound they have separating. Okay, so there is a bands, like a bands it's a separating. Initially the only silica gel is added here, this making a the slurry. Here there's a stationary phase plus there's a compound or sample only here. Okay, this is a cotton, this is a silica gel, and or especially stationary phase and compound. And once added the solvent, the affinity depends on that the compound have separating come to close here. Here there's for example this A and this B, this for C. Here the adsorption as a stronger, especially C. So the adsorption there's a C is greater B than A. So elution, what did happen? There's a elution, there's a A is greater, B lesser for C. So more elution, lesser adsorption. Okay, so that is a very important. So first case we can collecting that A compound. This A we can collecting. This A will again we go to the rotavapor, the evaporating the solvent, we can get in the pure compound. This is one of the separation technique. Okay, next TLC chromatography. Here the stationary phase as a solid. Okay, and mobile phase as a liquid. Okay, here there's a TLC plate is available commercially, is like that is presented. This plate is already quoted as a stationary phase. So now we can mark this borderline point. This is a borderline point. Now we can take it as a pure compound here, and here is our sample. This for that's a sample. Here is a pure compound. Okay, so now enter this TLC plate, dip on the beaker. Okay, dip on the beaker. That beaker already containing a solvent with a suitable polarity. There is a solvent. We can use it as a mobile phase. Okay, so this is a TLC plate is dipped on that solvent and kept in that with normal room temperature, as well as there is a atmospheric pressure. Without disturbance, we can kept in that TLC plate inside of that beaker. So now the solvent can move in that capillary action through the capillary action. The solvent is moved upward direction by the base of polarity. The solvent and the component also can be separated. For example, there's a pure solvent, pure sample we can spotting here, and there is a here one spot from our sample, and there is a here one sample and here one sample. So in our expecting product, expecting spot, in our expecting part, this is our expecting part. Okay, this is a purest form. This also there is our expecting product. So this part only we can crack out. We can collecting the solvent dissolve. After that there is a evaporated. We can get the pure solvent. The remaining these all are the same impurities. Okay. So anyway, here there is a once upon this column using before that this TLC also is very essential, because column and TLC have the handling very important in the research field, whatever that is separation field. The mobility, especially solvent, is greater than compound. So anyway, the RF is a very important. That's a retention factor. The RF is always less than 1 because the solvent has a greater mobility compared to the compound. Here the RF is equal to, it's a compound distance, compound movable distance divided by, it's a solvent movable distance. There is nothing but for that RF. So already we say that the solvent has a mobility is greater, so there is a more distance is initially the solvent is movable as well as compared to that compound. So therefore the RF always whatever the R always is less than 1. Okay, so this is a very important, sometimes asking the question. The RF is very important initially. Okay, the next is a paper chromatography. It's a paper chromatography. Here is a stationary phase as a liquid and mobile phase as a liquid. Both as a liquid, that's why there's a partition principle. Okay, there's a partition principle. Initially studied, there's a column as well as TLC chromatography as a adsorption principle. Okay, so this is a partition principle. Here glass as a supporting material, glass as a supporting material. Okay, supporting material. Okay, anyway, similar like that TLC, we can dip on that solvent containing beaker. The difference. Next is a paper chromatography, stationary phase as a liquid, mobile phase as a liquid. There is a both as a liquid, there's a partition principle. Here the using as a glass as a supporting material. That's why it's a similar like of TLC chromatography. We can dip on that paper chromatography into the solvent containing beaker. The solvent is movable as greater compared to the compound, like that, etc., etc. That's always is similar to of TLC. Just we can finding the RF value. Then we can compare that pure compound and our sample of compound. Then we can crack out that exact pure solvent near of the spotting that is soluble into that suitable solvent. We can do that. Okay, that is enough for that NEET as well as JE. Okay, thank you to all everyone. If you like this video, subscribe. Thank you everyone.